So in the last lecture we have covered all module 1, right? DC circuit, each and every topic was covered. Now we'll start with the module 2, that is AC circuits. So from that I'll tell you the basic thing. Okay, so let's start module 2, that is AC circuit. First of all, you should know the difference between the DC and the AC, right? DC is always in the form of battery, right? And can you tell me, like, we are having a socket like this at our home. So which kind of supply we are getting from these sockets? AC supply or DC supply? It's AC supply. Okay. Wherever you are having battery, like in phone you are having battery, so in laptop you are having battery, that is the DC supply you are providing to the phone and laptop. But from the charger, because you connect the charger to the socket, correct? So that socket always provides AC supply. Okay, clear? Now generally in AC circuit we'll use three kind of element. One of the element is resistor, another element is inductor, and another element is capacitor. In resistor is denoted by R, inductor is denoted by L, and capacitor is denoted by C, right? Resistor standard unit is ohms, right? That is denoted by ohm. Inductor standard unit is Henry, that is denoted by H. Capacitor standard unit is farad, that is denoted by F, right? But maximum of the time you will get the inductor value as millihenry. Okay, so you need to convert it into the standard unit. What is the standard unit? 1 millihenry is equal to 1 into 10 raised to power minus 3 henry. Okay, and you will get farad as the standard microfarad. So 1 microfarad is equal to 1 into 10 raised to power minus 6 farad. Got it? Ohm, generally you will get it in ohms or kilo ohm maybe. So 1 kilo ohm is how much? 1 into 10 raised to power 3 ohm. Clear? Now what is the function of resistor? Resistor symbol is like this, inductor symbol is like this, and capacitor symbol is like this. You already know about it. What is the function of the resistor? It opposes the flow of current, right? It opposes the flow of current. What is the function of inductor? It also opposes, but what it opposes? The change in flow of current. Okay, it won't allow the change. Like if you are continuously changing the current, then inductor won't allow the change current to pass through it. If from the very long time your current 10 ampere is flowing from the very long time and current is not changing, so it will easily allow to pass the current, but it will not allow the changing current. Got it? Clear? Now capacitor function, it stores energy. What it does? It stores energy. Clear? So we'll have resistor, inductor, and capacitor, right? Now I'll ask you one simple question. We are having one plain wire and we are having one wire with a resistance. In which case current can flow easily? The plain wire or the resistance one? The plain wire, right? Resistance supposes the flow of current. If you are again having a plain wire or the wire with the inductor, then in which case current can flow easily? The plain wire or the inductor one? Plain wire. Inductor opposes some amount of current, right? So that means there is some amount of resistance present in the inductor. Yes or no? That what opposes actually, the resistance opposes now. So there is some amount of resistance in already present in the inductor. We didn't add any resistance, right? So that technically resistance is known as inductive reactance. Okay. Inductive reactance is denoted by X L, right? And XL formula is omega L. What is omega here? Omega is the angular frequency and its formula is, as you said, that is correct, 2 pi f. So XL is equal to how much? 2 pi FL. So can you tell me what should be the unit of the inductive reactance? That was the unit for L. L unit is Henry, right? Now I'm asking the inductive reactance. So if I write it, the definition of inductive reactance, that is, it's a kind of resistance, right, offered by inductor, correct? Kind of resistance offered by inductor. So according to you, what should be the unit of XL? It's the resistance only. Yes, its unit is ohms. Clear? Okay. Now I am again asking the same question. If you are having a plain wire or the wire with a capacitance, in which case current can flow easily? Wire without capacitor, the plain wire. Okay. So that means there is some amount of resistance present also in the capacitance, and that resistance is technically known as capacitive reactance. Okay. Capacitive reactance is denoted by X of C, right? XC. So XC is how much? XC formula is 1 over omega C, and 1 over omega is how much? 1 over 2 pi FC, and its unit is also ohms. So what we can define capacitive reactance? It is also the kind of resistance offered by capacitor, right? Understood? Now see what you have studied. If you are having resistor, then its resistance is resistance only. If you are having inductor, then its resistance is denoted by, tell me, XL, right? If you are having capacitor, then its resistance is denoted by L for XL and C XC, right? But what if we'll have combination? Like we can have the combination also, right? Maybe the combination of R, L, or we can say RC, or we can say RLC, right? We never have a combination of L and C. Understood this point? Okay. So in this case, we'll have an impedance. The combination of two elements or more than two elements, then their resistance is technically known as impedance. Okay. And do you know impedance is denoted by the term Z? You have studied this in 12th class also. So we'll have particular formula for Z. Z is equal to root of R square x whole square. Z is equal to root of R square plus x whole square, and here there is no only L, so it would be Z would be equal to root of, tell me, XL whole square. So all these are kinds of resistance only, so its unit is ohms only. Correct? Understood? Any doubt up to here? Okay. Now we'll have three kinds of triangle. Okay. One, we are having impedance triangle. From these three triangles, your all concept of AC circuit or AC power will be covered. Okay. From this simple triangle. Now this is the impedance triangle. So that means all are containing the form of resistance. Yes or no? In the base we'll always take resistor resistance. In the perpendicular we'll always take inductor resistance, that is XL, or capacitor resistance, that is XC, or the combination of these two would be Z. Z means impedance, right? And the angle between them is always phi. Clear? Now you need to apply the formula. This is a right angle triangle, right? In right angle triangle, we can calculate sine phi, can calculate tan phi and cos phi, right? And we can apply the Pythagoras theorem also, that is hypotenuse square plus perpendicular ka square plus base ka square, correct? Now you tell me what would be the formula for sine phi. HB. See that if there is a circuit of RL, then we'll take XL. Okay. If they have given the circuit of RC in the paper or in the question, then we'll take XC, right? But if they have given the combination RLC, then that depends. If XL is greater, then we'll take XL minus XC, or if XC is greater, then we'll take XC minus XL. Clear? So here sine phi is how much? Perpendicular over hypotenuse. Can take XL minus XC by C. Cos phi is how much? R by Z. Tan phi is how much? XL minus XC by R, right? So from here, can you get the value for phi as well? Like suppose we have taken cos phi. Cos phi is R by Z. If we need to calculate phi, then phi is how much? Cos inverse R by Z. Okay, what is this phi over here? Phi is the phase angle between voltage and current. Okay, basically we'll have voltage and we'll have current, right? And the angle between them is known as phi. Clear? It may be on the upward side, it may be on the downward side, that depends on the condition. Now you need to apply the Pythagoras theorem. Can you tell me Pythagoras theorem, hypotenuse is how much? Z. It would be Z ka square. Perpendicular or base is how much? R ka square. And perpendicular is whole square. So Z is equal to how much? Of arc square plus XL minus XC ka whole square. So see, we got the same formula which we got it here. I told you directly, but now you know the formula, that how this formula comes, right? Any doubt up to here? Okay. Next one is, if we'll multiply current with the resistance, then what it will become? Can you tell me? It will be it will become voltage, right? According to Ohm's law, V is equal to IR. Now we'll draw the impedance triangle and multiply current, then we'll get voltage triangle, right? Like here was R, XL or XC and Z. So here we can multiply current R, I into XL, I into XC and I into Z, right? So this will become a voltage triangle. Voltage triangle is, on the base we can take VR, right? VR is the voltage across resistor, right? Or in the perpendicular we can take VL or VC. VL is voltage across L, VC is voltage across C, right? Here V is the total voltage, because total current and impedance is total combination, right? V is the total volt. Understood? So what we got, the formula VR is how? I into R. L is how much? I into XL. C is how much? I into XC. Similarly, can you get sin phi, cos phi and tan phi and apply Pythagoras theorem as we done in the previous case? So sin phi is this one, cos phi is this one, and tan phi is this one. And by applying Pythagoras theorem, we are getting this formula. Correct? Now, in the next case, you need to multiply voltage with the current. After multiplying voltage with the current, what we can say in power. Good. So basically in AC circuit, we'll have three different kinds of power. One is the active power, another is the reactive power, and another is the apparent power. Okay, you need to remember all the three powers. Active power is denoted by P, reactive power is denoted by Q, and apparent power is denoted by S. Active power is used where resistive load is there. Reactive power is used where inductive or capacitive load is there. Apparent power is used where there is a combination of RL, RC and RLC. Okay, here L or C. Active power formula is VI cos phi. Reactive power formula is VI sin phi. Apparent power formula is VI. Okay. Active power standard unit is watt, that is represented by W. Reactive power standard unit is AR, that is represented by volt, ampere, reactive, and apparent power unit is VA, that is volt, ampere. Okay. Active power, another name is real power, or we say true power. Active power where we are using resistive load, we are using at our home, right? Like bulb or whatever appliances we are using at our home, that is active power consumed. Inductive and capacitive load mainly we are getting as a in a factory like industry where we are running induction motor. Okay, so it would be in industries, you can say. Apparent power where mainly we are using transformers. Okay, note this down, this is very important. Basically, apparent power is the combination of active power and reactive power. I'll give you one example. Like you have seen a cup of beer. Have you seen a cup of beer? So in a beer, you are having beer up to here, right? In the real which you drink, that beer is up to here only. Above one are all blue color are froths, right? So the actual drink of beer is the real beer which which you will be able to drink, that is the active power. Okay, but you have to pay for the froth as well, right? That is not the real, that is the reactive power. And you have to pay for the whole glass, the active power and the reactive power, that is known as apparent power. Okay, beer is the real power, froth is the reactive power, and the combination is known as apparent power. Or we can say, I'll give you one more example. You are having a chips, Lay's chips, right? So in 10 rupee chips, you get 4, 3 or 4 chips, which you actually consume, right? So that is the real power which you actually consume. All other are gases, that is reactive power, and the combination of gas and chips is apparent power. Understood? Now you will never forget in your life what is active. Now after this, as I told you, we need to multiply voltage with the current. So next triangle is the power triangle, right? In the power triangle, where base, which power consume resistive load? Tell me. P. And which power consume? That is reactive power, which inductive and capacitive, and the combination is known as apparent power. Okay, understood? Okay. So we'll have S square is equal to P square plus Q square, right? And can you tell me what is cos phi in this case? Sin phi by S. Sin phi is how much? By S. And tan phi is how much? By P. Understood? Now see, you have listened one more term about, that is power factor, right? Power factor is nothing but it is cos phi only, but it is cos phi. So if you calculate cos phi from the power triangle, then power factor is P by S. Okay. Some of the student misunderstood that it's phi. No, it's cos phi, cosine of angle between voltage and current. And if you calculate it from the impedance triangle, then cos phi is R by Z. And if you calculate voltage triangle, that is VR by V. So whatever they have given, that depends, but they have given, we calculate according to that only. Understood? Now next topic that comes in exam is phasor diagram, right? Let's do later on phasor diagram. Let's do first numericals based, otherwise there will be of confusion, right? Now see, these are the two questions that they get it in CAT exam, right? CAT 1 August 2020. You will also get these kinds of question, okay? You will not get any another kind of question. हर किसी का same pattern will. So now in this case we can do the B part. I told you the concept and we can do the B part. Let's read the question what they have said. In this they said this is of 7.5 marks, right? 15 marks is there now, so this is of 7.5 marks and this is easy, I'll tell you. Now see what they have said, we have to draw the diagram. Okay, they said a capacitor, so draw the diagram of the capacitor. Okay, they said resistor, so it's better to draw resistor first because always we'll write it like this, na, resistor and capacitor, RC, RL, RLC. Okay, draw resistor. They said it is connected in series AC supply, right? It's an AC supply. AC supplied circuit is like this. Okay, don't draw DC supply. This is DC supply, this is AC supply. Now they said supply they have given is much, that is 60 volt. So mark it here only 60 volt, and frequency is how much? 50 hertz. So 50 hertz. Okay. So whatever they have given you the value, write it inside also. That voltage they have mentioned is volt, that is the total voltage, and frequency they have mentioned as 50. Okay, the current is 2 ampere. You can mark the current here. I is equal to 2 ampere, so mark it as I is equal to 2 ampere, and the power dissipated in the resistor is 80 volt. Power across resistor, right? They mention it's across the resistor only, it's not the whole power. So power across the resistor is how much? 80 watt. Yeah. Now you need to calculate impedance, need to calculate resistance, calculate capacitance, calculate power factor, and power factor, as you already know, that is cos phi, right? Okay. Now write down the formulas as you know. V is equal to, according to Ohm's law, IR, right? But if there is a combination of RC, then R is replaced by impedance, right? R is replaced by impedance. So V would be equal to I into Z. So now this is your new formula. You can't use equal to IR whenever they'll give you the capacitor or inductor. Then in that case, you need to use V is equal to IZ. Clear? So mention V equal to IZ. Do you know V? That is 60. Do you know current? Can you get Z? 30. Got it? 30. Understood? Now calculate resistance, right? They have given you power, and what is the formula for power? P is equal to I square R. Power is given 80, I is given, R is not given. So 80 by 4. R is how much? 20 ohm. R also we got it as 20. Now next is capacitor. Cos phi capacitor, you know the formula Z is equal to, I just told you, root of R square plus XC square, right? Do you know Z? How much? 30. Do you know R? A whole square plus XC square. Can you calculate XC? That is root of, or we can say 30 ka square minus 20 ka square under the root, right? 30 ka square is 900, 400. Calculate it and then tell me the value. XC you got it as 22.36, right? So you know XC is how much? XC is equal to 1 over 2 pi FC. 2 we know, pi we know, F we know, XC we know. Can we get C? Okay, you can get C, you can calculate it by your own. Cos phi formula is according to impedance triangle. R by Z. R do you know? Z do you know? 20 over 30. So how much it is? One thing also you must need to remember that about the power factor, that power factor always lie between 0 to 1. Okay. If you are getting some greater value than 1.1, then that means you have calculated wrong. It always lies between 0 to 1. Okay. For resistive load, cos phi is always 1. And for inductive or capacitive load, it may be less than 1. Okay. So it is always the must condition. Clear? Now this question is clear. Now next question is also from your CAT1 exam from 2020. Okay. Now read the question by your own first and then tell me how we can solve. See in this question, this is from 2023. A resistor of 20 ohm, okay, and inductance and capacitance are connected in series across 220 volt 50 hertz. Okay, so it would be 20 ohm, 0.2 Henry, 100 micro. Determine impedance, determine current, voltage across R, VR, voltage across L, VL, voltage across C, and phasor diagram. So z is equal to root of r square plus xl minus xc का whole square. xc c you need to convert it, 100 into 10 raised to power minus 6, right? I is equal to how much? I is equal to v over z, not r. Vr is equal to I into r. VL is equal to I into XL. XL you already calculated in Z, right? VC is equal to I into XC, correct? Okay. Now the next category of question like this, they'll give you another question like this only. We'll have one standard equation that is for voltage equal to Vmax sine omega t plus phi. Okay, like as you already know, voltage is like this, voltage waveform is like this, right? So Vmax is the maximum voltage and this is in the sinusoidal form, right? This form is sinusoidal form and on the x-axis we'll have omega t. So that's why the standard equation is V equal to Vmax sine omega t plus phi. Similarly for current also we'll have I is equal to I max sine omega t plus phi, correct? So for always for calculation purpose we need to calculate RMS value. I think you have already studied about RMS, that is root mean square. What is exactly the root mean square? Like suppose this is the waveform and you have taken voltage at each and every point, like you measure voltage V1 here, V2 here, V3 here and up to so on it goes up to Vn, right? So VRMS stands for root mean square. Root mean V1 ka square, V2 ka square up to so on Vn ka square divided by n. Okay. So now if I'll ask one question that at your home you are using 220 volt supply, what is n is the number how much you have calculated. Okay, like no, you don't need to find n, you don't need to find n, I just tell you the basic. Now I was asking at your home you are using 220 volt, right? So according to you, is this VRMS or Vmax? Yes, correct. That is, this voltage is VRMS. So for always calculation, we use VRMS, and there is one relationship that you can write it down in the formula page also, that VRMS would be equal to Vmax divided by root 2. Okay. Similarly, IRMS is always equal to Imax divided by root. Whenever they'll give you in the form of equation, they'll give you Vmax, right? We want to convert it into RMS. Clear? From this you can get it. No, if they give you in the form of equation, okay, like this kind of equation, like in this they give 60 volt, that is the RMS. But whenever in the numerical they'll give you the equation, they'll 100% give you the in the form of maximum. Clear? So this is again your CAT1 exam paper 2024. In this they have given V is equal to 200 sine 314t plus pi by 6, right? And I told you the standard equation that V is equal to Vmax sine omega t plus phi. If I'll compare it, Vmax is how much? 200, so we can write it down. V is equal to 200 and omega is how much? 14, so we can write down omega is equal to 314. phi is how much? Pi by 6. So we write it down. Phi is equal to pi by 6, right? Got the value? Similarly, they have given the current value. I is equal to 20 sine 140 minus pi by 3, right? So I max is how much? And omega is same 314. And current angle is how much? Minus pi by 3. Okay. Now let's see what they have asked. They asked you to calculate frequency. So we know omega is equal to 2 pi f. Omega is how much? 314 is equal to 2 pi f. So f is how much? 314 divided by 2 pi, right? Pi is 3.14 only, so you can get it. You will get frequency as 50 hertz, right? Now in the next part they have asked maximum value of voltage and current, that we already calculated by comparing the equation. V max is 200, I max is 20, right? Now in the next question they ask you the RMS value. RMS value, I told you the formula. V RMS is equal to max, so that would be divided by root 2. Whatever the value you are getting. IRMS is how much? I max by root 2. 20 by root. Okay. Now they are asking average value of both voltage and current. So average value, write down the formula of average value also. Formula page. V average is equal to 2 V max divided by pi, and I average is equal to 2 I max over pi. Okay. So you already know the value of this one, maximum, and then you will obtain it, right? Now in the next part they ask you the circuit element. Circuit element, whether it's a combination of R, L and C. See how can we get it? As you know, V is equal to how much? IZ. So Z is how much? V over I is how much? 200. I is how much? 20. Z is how much? 10. Understood? Impedance is 10. But impedance can be R, can be RL, can be RC, can be RLC, right? So for this you must know about the phasor diagram. Basically, in the phasor diagram, again we'll have three kinds of load. One is resistive load, right? One is inductive load. One is capacitive load, correct? In resistive load, current and voltage are in same phase. In inductive, current lags voltage when an angle of 90 degree, or we can say pi by 2. In capacitive case, current leads voltage by an angle of 90 degree. Okay. See, how can you remember in which case it is lagging, it is leading? You must need to remember this word civil. Okay. C stands for capacitor. In capacitor, current is first or voltage is first? That means current is, okay. And obviously in inductor, that is opposite, current is lagging. Same phase means, like suppose generally what will take, voltage will take on the x-axis, right? So current is also on the x-axis. Clear? Similarly, here voltage is on the x-axis and current lags. Lags means on downward side 90. Here voltage is there and current lead by an angle of, got it? Now back to the question. Here one of the angle is pi by 6. Pi by 6 is how much? So pi by 6 voltage angle, how much they have given? 30 degree, right? Voltage angle they have given as 30 degree and current angle they have given as minus 60 degree. If I'll draw the phasor diagram, 0 is this one, 30 degrees above voltage angle, minus 60 degree, that is on the downwards. Okay, now can you tell me in this case 60, this is 30, voltage is leading or current is leading? That means current is lagging, right? So if current is lagging, that would be an inductive circuit, right? So inductive circuit means it is the combination of R and L. And how much is the angle between voltage and current? 90. So if there is a pure phi angle is 90, that means no resistance is there. It's the inductive circuit, right? And if it's an inductive circuit, so Z value we got it as 10. That is XL is equal to 10. Okay, clear? Similarly, you can obtain any of the value. If they suppose we'll get phi is equal to 60 degree, then that means that would be the combination of R and L. Okay, so you have to see which thing is leading. Accordingly, you can decide the element, which element. So they said circuit element is L, and you got XL, right? Got XL as equal to Z, that is 10 ohm. So can you get L? XL is equal to 10 ohm. When XL is equal to omega L, then we will get L value, because they are asking the L value. So element means L value they are asking. Understood? No, circuit element is element XL, element is R, L or C. So now we obtain, if it's a pure inductor means phi is 90 degree. If phi is 90 degree, it's either pure inductor or pure capacitor. Write down this point also. If it's a pure inductor means phase angle is 90 degree and current is lagging, then it's pure inductor. If phase angle is 90 degree and current is leading, then it's a capacitor. If phase angle is 0, okay, then in that case it's a pure resistor. They said first of all coil. Whenever they said coil means is the combination R and L, nothing else. Okay, coil means R and L. So whenever they say coil, draw the diagram of coil, that is R and L. R value they have given as 100 ohm and L value they have given as 200 millihenry, means 200 into 10 raised to power minus 300. If an alternating voltage they have given like this, means voltage is how much? 200 by root 2, because they give you in equation form. Okay, and omega is how much? 77. So from this omega is equal to 2 pi f, you can get the value for f frequency, right? So omega is 377, you can get frequency. Then after that they ask you to calculate impedance. Impedance is how much? That is Z is equal to root of XL minus XC का whole square. Next, current I is equal to, and next put 200 divided by root 2 divided by the impedance value which you got it. Okay. Next they ask you to calculate potential difference, means VR. Here is I into R, I you know, R you know. VL is I into XL also they have given. Next you need to calculate phasor diagram, and then you need to calculate phase angle between voltage and current. Phase angle means phi, right? And phi means cos phi. Can we get cos phi? R by Z. R we know, Z we know. Then we'll get phi is equal to cos inverse of R by Z. Now see next question from your paper only. In this they said a 240 volt 50 hertz supply is applied to a coil. Coil, as I told you, resistor and inductor, right? Resistance value 4 ohm, inductance value 0.08, and that coil is connected with the capacitor, that is 8 microfarad. So here only you can write it down, 8 into 10 raised to power minus 6 farad, right? Calculate the impedance. Voltage is given 240 volt 50 hertz. Now you can get impedance, that is R ka square plus XL minus XC ka whole square, right? Then you need to calculate current. Current is V over Z. Then you need to calculate phase angle. Phase angle is phi, means cos phi is R over Z. Then phi you can get it by the similar way, cos inverse R by Z, right? Then they are asking the power factor. Power factor you already calculated, cos phi. Then the power consumed by passive element. Passive element means inductor and capacitor. Power consumed by passive component means they are asking for the reactive power. Remember I told you the three different types of power. Passive component means they are asking reactive power, that is VI sin phi. So already calculated I. If you know the value of phi, then can you get sin phi? Or if you know the value for cos phi, can you get the sin phi? So now you can solve it. Easy. Now see what topics we have covered. Power in AC circuit, power factor, single phase RL, RC and RLC circuit, RMS value, average value, maximum value, alternating voltage current. Half of the AC circuit is completed from my side this 1 hour, right? Now the last question I gave, then over. See, in a series RLC circuit, RLC, the circuit is excited by a 30 volt 50 hertz, right? Current is how much? Ampere. Calculate L. So V is equal to IZ 30. Current is 8. They have, can get Z. Z is equal to of R ka square plus XL minus C ka. Z value we obtain it. R value they have given. XC we can get it by C. XC is equal to 1 by 2 pi FC, right? So we know Z, only XL is unknown. XL we can get it. After XL is equal to 2 pi FL, can get L, right? Then we need to calculate active power. Active power formula is P is equal to cos VI. VI we know, cos phi is R by Z. right? Reactive power is Q is equal to I sin. Apparent power S. Apparent power is also known as complex power. S is equal to VI for the phasor diagram. Okay, now, as you know, your CAT exam is near. If you have any doubt or if you ask me any, contact me on this number. You can ask me your query, or you can post me, or you can drop me a message, whatever you ask, I'll help you. Okay, so I'm teach IT student from past 9-10 years, so I know the pattern of IT. I have all previous year question paper. I have which your teacher will provide to you. I have every material. If you have any back, or if you want to study any of the module from this syllabus, you can contact me on this number. My name is Charujan. Thank you.